Hello, geometry students. So we're at a point you just watched a YouTube video about the difference between precision and accuracy. Remember, precision is are all your points very close together. So they used a target analogy, but if I'm measuring, maybe I measure the I have maybe a pencil that was sharpened, and I hand it out to all the students here, and I ask each student to measure that. If we're precise, that means everybody's measurements came out very, very, very close to being the same thing. Um, but if we're accurate, it means that everybody's measurements came out very, very, very close to the exact measurement that the pencil really is, whatever that might be. And so that's the difference between precision and accurate. It's possible, like we saw in the video, for things to be precise but not accurate, accurate but not precise, both accurate and precise. That would be like hitting that bullseye target every time, or neither one, neither accurate nor precise. So we'll work with that a little bit. But the next step then is to talk about what we call absolute error. Absolute error. So say this is part of a ruler here. Maybe this is like 8 inches, 9 inches, 10 inches, 11 inches, 12 inches. And I say we're going to measure an item, and the item we're measuring, some people started measuring at 0, of course, but we're going to take it from here and say that for them, the item they're measuring is about here. And then somebody else is measuring an item, and or we're taking a second measurement, and it's about here. And I say, okay, I want you to round to the nearest whole inch. Remember, this is 8 inches, 9 inches, 10 inches, 11 inches, 12 inches. Both of these segments are closest to hole number 10, right? And how do I know then that I would take both of these? This one's under 10, but I would round it to 10. This one's over 10, but I would round it to 10. So how did I know that I should round both of these to 10 and not back this one off to 9 or maybe this one up to 11? It's because they're over halfway, right? So if these are whole inches, half of one whole is 1/2 an inch. So anything that's lying here between a 1/2 inch under 10, that would be at 9.5, up to 1/2 inch over 10, so this would be 10.5. Anything that's measuring somewhere between 9.5 and 10.5, when I say round it to the whole inch or the nearest inch, we would round to 10. So we went a 1/2 inch below 10 up to a 1/2 inch above 10. So when I'm rounding to the whole inch, the absolute error is 1/2 inch. The absolute error is always 1/2 of the units you're measuring in. All right, well, whole numbers, that's not so hard. But let's say that this is my 8 inches, and this is 9 inches, and I say I want to round to the nearest 1/2 an inch. Well, what's half of a half? Half of a half is 1/4. So any measures that are 1/4 away. So let's see, here, 1/4 below, and again, I want to go to 10. So here's, well, let's see, this I said was 8, 8.5, 9, 9.5. And so here's the half of a half, a 1/4 of inch below 9 point or 9 point or 9 and no fraction. And this is a 1/4 of an inch above 9 and no fraction. All right, so if I want to round to the nearest 1/2 an inch, then again, both of these would round to 9 with no half, no fraction part, because I'm within fourth inch above and a fourth inch below. That wasn't a very good example. I should have thought that one out a little better. Let's say that these are centimeters. And so, and I'm going to say that from here to 1, 2, 3, 4. Okay. So if this is a whole centimeter, again, say let's this is 8 centimeters, and these are millimeters this time. So this is 8.1 centimeters, 8.2, 8.3, 8.4. And I say I want to round to the nearest tenth of a centimeter. Well, what's a half of a tenth? If I say tenth, it takes, and then the next, or half of 1/10. Half of 1/10. Well, 1/10 is like 10 hundredths. This goes back to the metric idea. 1/10 is like 10 hundredths. And then half of 10 hundredths would be 5 hundredths. So 5 hundredths is my absolute error. All right, 5 hundredths is my absolute error. So again, anything that's 5 hundredths below this mark up to 5 hundredths above this mark. So the point is to find what is that absolute error. What's that half of a unit we're measuring to? If I look at the examples on page 22, example 1 there has part A. And part A says if I'm measuring something to 6.4 or 6.4 centimeters, what's the absolute error? Well, again, we're measuring to 4 tenths. So tenths is my units. And then half of tenths we said was 5 hundredths. So anything that would measure from 6.35 centimeters, that would be 5 hundredths below 6.4, up to 6.45, that would be 5 hundredths above 6.4, would round to 6.4. All right, so that's my absolute error. You can see right above the little ruler there, they have written 6.4. That sign, it looks like a plus sign with a line under it. We call that plus or minus. You're going to add a half, or that 5 hundredths to the 6.4. You're going to subtract that 5 hundredths from 6.4. That's the interval that we would round to make 6.4. Anything that lies from that 6.35 up to 6.45 would round to 6.4. All right. Let's move on. The next term that we want to talk about then is something called significant digits. And significant digits, again, if you look on page 23, there's a little set of rules there about significant digits. There are 4 bullet points there that are the rules. It says to determine whether digits are significant, if they have meaning, if they need to be there. It says use the following rule. Any non-zero digits are always significant. Really, the only thing we have to be concerned about with significant digits are zeros in a number and whether or not they're significant, whether or not they're truly important. So non-zero digits are always significant. Anything that's a 1, 2, 3, 4, 5, 6, 7, 8, or 9 is going to be significant. In whole numbers, zeros are significant only if they fall in between some non-zero digits. In decimal numbers, if the decimal number is greater than or equal to 1, all the digits are significant. If the decimal number is a number less than 1, then the first of the digits that's not 0, and all the rest of the digits to the right of it, 0 or not, are significant. So let's look at some examples in example 2. So the first one, A, so let's see, 430.008. Well, which kind of number is this? It's not a whole number, it's a decimal number. and it's a decimal number greater than or equal to 1. So it's the third bullet point. So it says every digit is significant. So let's see, there's 430008. That's 6 different digits. So this one has 6 significant digits. If I look at example B, well, this is also a decimal number, 0.00750. And this is the fourth bullet point. It's a decimal number, but it's a number that has a value less than 1. So the first of the non-zero digits, that would be the 7. And then all the rest of the digits to the right of that. So the 7, 5, and that 0 on the far right, those are all significant digits. So this particular number has 3 significant digits. The 0 on the far left, to the left of the decimal point, and the first 2 digits on the right of the decimal point, those are not significant. It's the 750 that becomes significant. The guided practice problem there, the 2A, well, let's see, what kind of number is that? It's a whole number. It's not a decimal number now. It's a whole number. So let's see. If I go to bullet point 2, the second bullet point, it says whole numbers, zeros are significant if they fall between non-zero digits. Well, these don't. There's 3 zeros here, but they're all after the 7 and the 7 and the 9. So there's only 3 significant digits here, 7, 7, and 9. We don't count the zeros as significant. In 2B, again, I have a whole number greater than 1, but this time the zeros fall in between the 5 and the 8. So then we do count them as significant digits. So 5, 0, 0, 0, and 8 are all significant digits here. For the last one, the 2C, well, let's see, it's a decimal number, but it's a decimal greater than 1. So all the digits are significant. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 different digits here. They are all significant, 9 significant digits. All right. Well, that brings us to something called relative error. The last part that I want to talk to you about here is called relative error. Relative error, anytime we use the word relative in mathematics, it means you're talking about percent. You're going to have your answer is going to be a percent answer. And so when I look at this, it says a manufacturer measures each part for a piece of equipment to be 23 centimeters in length. Now we know that it's almost impossible to get exactly 23 centimeters each and every time. So they're looking then at a relative error. How much are they going to accept to be 23? And so it says to find your relative error, you take what we call that absolute error, that half of the unit. So we're measuring at 23 centimeters, so a half of a centimeter, and divide by the measure we're looking for, that 23. So 0.05 divided by 23 gives us 0.22, but we remember I want this in percent, so I multiply by 100% to move that decimal 2 places, and I get 2.2%. That's what's called the relative error for this measurement. Again, look at the guided practice down below. If I have something 3.2 miles, well, my absolute error, I'm measuring to 2/10 or tenths of a mile. So my absolute error is 5/100 of a mile. So if I subtract 5/100, I'm at 3.15. If I add 5/100, I'd be at 3.25. But 0.05 is my absolute error. So I take the absolute error and divide by the measurement, the exact measurement, 3.2. And then of course change that to percent. And so this one actually, if you do it on the calculator, comes out to about 1.6%. 1.6% isn't bad. We would accept 1.6% as relative error most of the time. It's not a very high number. It's not a very high percent. But if I look at 3B, I want the absolute or the relative error for 1 foot. Well, half of 1 whole foot is a half a foot. So if I go half a foot below 1, I'm at 1/2, right? 1 minus 1/2 is 1/2. If I go half a foot above, I'm at 1.5. So half a foot is my relative error, or my absolute error, sorry, my absolute error. Divide that by the 1 foot that we're looking for. So 1/2 divided by 1 is still 1/2. What is 1/2 as a percent? I'm sure most of you can figure that one out. 50%. That's a big relative error. I can be a whole, half a foot in either direction. That's a pretty big error when I'm only trying to measure 1 foot. Something like 1 foot is 12 inches, right? So if I measure something and get 7 inches, that's pretty far off. I didn't do a very good job of measuring if I call that 1 foot. Or if I have something instead of my 1 foot should be 12 inches. If I have even 14 or 15 inches and I'm calling that 12 inches, I didn't do a very good job of measuring there. That's pretty far off. So 50% error, I'm sure, is unacceptable. We would say, no, you didn't do a very good job of measuring it all. All right, so there are a few more problems I want you to do on this last page, page 24, 2 through 22 even. Now, as you're working on this, you might well have some questions along the way. So be sure and ask questions, and I'll try and demonstrate on the board. We'll do a lot of this together, I have a feeling. So good luck.